All right. Good to see you all today. Let's talk about some of these homeworks. Today, it's going to be a pretty chill day. Nothing too extraneous, which is great. All right. What kind of questions did you come across on page 65, 66? Questions? 5. You got it. Problem number 5, we have, we're going to use this equation. This is called point slope, right? And then we have some graph that's given to us. It looks like this. And we know that this line does this, and they told us, hey, we have you got that. So they gave us that information. So, we don't really have the slope yet, do we? What should we do? Can we find the slope if we have 2 points?
Sure, yeah.
Make sense? So let's do that first. Let's find the slope. So I'm going to go say 2 minus 1 and negative 1 minus negative 4.
Sorry, not hold up. Keep going.
Oh, I was like, what did I do? All right, so I just went 2 minus 1, negative 1 minus negative 4. Is that okay? So 2 minus 1 is 1. Is that okay? Is that okay? Is that okay that I found the slope? What do you think? Is there anything about me finding the slope that we're goofed up on? This is a great question to ask for. Thank you for asking. Now, here's the goofy part of this problem. I have said you can label the points x1, y1, x2, y2, and it doesn't matter what order, correct? I mean, just don't mix x1 and y2 together, correct? Okay. So let's do this. Does everyone feel comfortable how I found the slope? Do I need to explain anything more to that? Are we okay? So watch this. I'm going to label this x1, y1, and I'm going to label this x1, y1 as well. Not because I want to confuse this, but we're okay. We already found the slope. The reason I'm going to do that is if I use this point right here, I'm going to get y minus 1 equals 1/3 x plus 4. That comes from this one. And then if I use this one here, I'm going to get y minus 2 equals 1/3 x minus 1, so x plus 1. What can you tell me between the red and the black answers? Do they look the same? Do they look different? Different. They do look different. Does everyone agree they look different? Not because they're just in different colors. They're just different altogether. Agree? Yeah. What if I were to tell you that they are the exact same equation?
I'd be shocked.
Think? What do you think? I mean, you all feel that by me looking at the black and the red that I just circled, I have 2 completely different equations. I have the same slope between the 2, agree? Right. But these do both look like they're completely different from each other. Yes? Okay, so let's do this. So I'm just going to modify this a smidge. I'm going to modify each one of those. Okay, so I'm going to distribute 1/3 here and here. 1/3 times 4 is 4/3. Is that okay? And then I'm going to add 1 to both sides. And I'm going to make the 1, so I have 4/3, I'm going to make the 1, because I'm adding it, I'm going to make it 3/3, because 3 over 3 is the same thing as 1, yes? So that'd be 7/3 if I do my fractions right. So does everyone feel comfortable how I did the math here? Now, I mean, you don't have to like love that I have fractions up there, but it is what it is. Do you feel comfortable that I was able to establish that? So let's do the same thing to this problem. I'm going to distribute here and here. What's 1/3 times 1? 1/3, right? I'm going to add 2 to both sides. All right, let me modify 2 to get a common denominator. If I wanted to make a 2 over the 3rd power, that means it's going to be 6 over 3. What can you tell me about those two equations? They're the exact same. Isn't that a little goofy? Kind of goes against a little bit of your thought process, but that's okay. So when you're working with point slope, you have to understand, like let's say you and your friend are working with point slope, and you labeled your points x1, y1, x2, y2, and your friend labeled theirs x2, y1, or x2, y2, x1, y1, so they went backwards. If you were just getting your answers to point slope, they are going to look different than each other. But you're both right. Okay? So point slope sometimes, hey!
Hey.
You all know Mrs. Thomas?
Hi guys.
Where would you like, here, you can sit in this comfy seat if you want, or sit in a chair.
Sit in the back.
Okay. We reserve
How are you? Good, lots of.
We reserve the back for guests. Unless you come in, you were in my 3rd period class. That was all full except for the one in back. So I love that you asked for this question, because this, if I were to just read answers out, I might only give the red answer or the black answer. And then someone's going to be sitting there going, why is my answer wrong? But you wouldn't have been wrong. So just, that's a safe thing to know. And we're going to work more with this. And this is a lot of critical thinking. And it happens that way. What other questions did you come across? Yeah.
On that one,
Uh-huh.
couldn't you just label it how you usually would with x1 and y1 and x2 and y2? And
Absolutely.
With it from there?
So what the hard thing is, you might have labeled it x1, y1, x2, y2, but someone next to you might have went x2, y2, x1, y1. Does that make sense?
Yeah.
So not everyone's going to exactly label the same way. Does that mean the person next to you is broken? Well, maybe, but not mathematically.
Okay, so it doesn't matter which number.
Yeah.
I still don't get why you switch the signs. So
Switch.
it's a positive, the y is a positive, like at the point, and then in the equation it turns into a negative.
Oh.
And so it does it.
Let's bring that up. Okay. So I'm going to go off this slide, and I think I'm going to try and address your question. Okay. So let's say we had this. This is my equation, right? That's the equation. That's the standard form, or that's our point slope form. So it's just another way of manipulating. Okay. So now we're just going to create something. So let's say we had, well, I don't know. Let's go -3, +2. Good so far? But then let's say we also know that we had a slope of -4 over 5. So from that point, I'm going to go down 4, right? And then to the right 5. So I'm going to go from this point, I'm going to go down 1, 2, 3, 4. And then I'm going to go right 5. 2, 3, 4. Okay, so that is just, if I had given you that point and that slope, that's what it would look like graphically. Agreed?
Yep.
Okay, so now, I think you're totally okay saying, hey, that goes in. No questions, right? So let's just see what happens here. So you're okay with that? I haven't plugged any points in, I just put the slope in. So now, why do I put the opposite sign in here and here? And this is heavy. This is a really tough thing to think about. Now I'm just going to give you the precursor. You're going to see this type of situation take place from math from here on out. Okay? Now, I'm going to show you where in Algebra 1 we get lazy. This is actually supposed to be in parentheses, but we get lazy. Okay? Now, this is the no nonsense. This is honest to goodness. Every time you see this, it's going to happen. If something's grouped, so it's in parentheses, in order to pull it out of those parentheses, it changes its sign. Every time. From here all the way through calculus and everything in between. Okay, so let me show you why this is going to work. My point is -3, 2. Okay? So I'm just going to tell you that right now I'm going to plug that in as y minus 2. That's where part of the issue is, right? Equals this. So that's part of your issue, saying, hey, why is that happening that way? Right? So this is the correct equation to represent that. Now, let me take it one step further. Okay? Let's think about if we had our y-intercept. Like, let's say we knew it was like 0, 6. Cool? So 0, 6, that's my y-intercept. Okay? Which, good. So y, let's do the cover method. Let's do the cover method. And let's say I knew this down here, so let's call that 1, 2, 3, and 4. Call that 4, 0, which is, we have a line, right? Okay, so if we do the cover method, which was the ax plus by equals c, right? Let's think about how this is going to work. Okay, 6x plus 4y. Hang on, let me just make sure that's going to work. Yes, that'll work. Okay, if I cover this up, I get x equals 4, right? If I cover that up, I get y equals 6. Both of those points legitimately work. Agree? Now this is exactly why the shifting is going to work for you. When I use the cover method on this equation, I find the x and the y-intercept. And you might remember I was doing this, 0, comma, blank, and blank, comma, 0. Right? So this means I'm covering up that. That gives me a 6. That means I'm covering up that, which gives me a 4, which totally agrees with this. So what's happening with this number is, man, just trying to get it, make it work in your head, Chris. There's a concept I want to show you, but it's like next semester, but I want to show you now. You trust me? All right. This forms something called a parabola. It's a shape that looks like this. Okay? The parabola, this is going to have a vertex, meaning a turning point there. You're going to see this next semester, so it's precursor. So, -2, 4. Because that's a 3, and it's positive, I'm going to go right 1, up 3. And here, up 3. Okay? That's what this graph looks like. And it's actually that easy to do, but people make it more complex. Okay. So take a look at where that exists there. Take a look at what that is there. Take a look what happened there. When it's grouped, it's opposite. Now, here's even goofier. Let's go even further. So that's a parabola. Let's do this. This is to the fourth power. Graphically, this looks like this, but there's a wiggle in between. Okay? So this is going to have a shift of this. And this graph looks like this. That shift should be right there. That's what it looks like. When I pulled this out, it went opposite. It shifted opposite. And that's the exact same thing that we're working with this. Even though it looks different, so shifts opposite because it's grouped. This also shifts opposite, but we're being lazy because we don't put parentheses around it. And that's such a deep thing. So as of right now, if you take something out and it's in parentheses, it will be an opposite sign number. If you put it back into it, you have to change the sign again.
So in the other slide, you have the 6 outside of parentheses, and that's why you didn't change it. That's 6.
Right. That's exactly right. Perfect. That nailed it. That is a huge idea. Because this 6 is not in a parenthesis, it stays that. And then if I go back here, this 4, it wasn't in a parenthesis, so it didn't change. So every time you see something grouped, and it could be using rounded brackets, it could be using square brackets, it could be making the ones that no one knows how to make unless you're a teacher. There's a whole lecture on teaching those. If it's grouped like that, it if it has an x plus or an x minus, you do the opposite of it. And it's a deep, rich idea, but it's great thinking. Great thinking. Okay? What else can we work on? All right, that was page 65, 66. So will you make sure your name is on it and just pass page 65 forward. So look at the bottom, see the page 65. Look at the top, see if your name's up there. If it isn't, please put it up there. Boy, I went got flu shot yesterday. Miss Thomas, you go get that yet? No. You get flu shots? Or you just roll the dice?
It just depends on the year. I did not get one last year.
Wait, what page? 66 or 65?
You get
65.
Just 65. So it is the smallest needle in the world. You will not feel it at all until the next day. It feels like you got a golf ball. Oh. So, work. So, but hopefully that prevents any widespread badness. Any more?
Give it to him.
Ooh, you're right. All right. So, as I said, I want to go kind of mellow today. And so, what we got? We got 19 minutes left. Am I doing that math right?
Yeah.
Okay. So, on this sheet of paper, it's the front and the back, I believe. And I just want to use this time. We're going to make sure we're caught up and we feel comfortable with the math we've been working on. So I'm going to do an example and I'm going to have you try. And then there's going to be a total of 8 problems we're going to do, and I'm going to do 4 of them. Okay? Sound good? Everyone have a sheet of paper? Oh, that's from Miss Thomas. She gets to do that as well. All right. Let's have a little bit of fun. And this is an all-access day for you. If there's something that you need me to go back over, let's do it. So this is my example problem. Let's do So this is going to be a straight line. Does everyone feel comfortable by me saying this? And this is a straight line that is in standard form. Does everyone feel comfortable with that? So standard form is going to allow us to use the cover method. And so the cover method works like this: 0, comma blank, and blank, comma 0. Agree? So those are just points, x, comma y, x, comma y. All right, so for this first one, I have a 0. What letter is this?
X.
X. So I'm covering that. So 4 times y equals 12. So what does y equal?
3.
3. So 0, 3 is right about here. 1, 2, 3. Okay. What value is this, x or y? It's a y. So it's a y, so I'm going to cover this up. So negative 6x equals 12. So what's x equal to? Looks just like that. Is there any part of that that we're not sure about? All right, so answer this question. Do you think the slope is positive or negative just by looking at it?
Positive.
It's positive. So if it's positive, is the graph increasing or decreasing?
Increasing.
Increasing. Agree? Okay, does everyone have that written down? Does anyone have any questions on it? All right, so the one I want you, just to the right of that, it says you try. I want you to try this one. Try that one. While you're doing that, I will paste up my grid. Okay, so you try that. Notice I do have the 0, comma blank, the blank, comma 0. See how you do. All right. Sophia, picking on you. Which would you like to do first? The 0, comma blank or the blank, comma 0? 0, comma blank. All right. So Sophia, is this an x or a y? X. So that means I'm going to plug it in here. So that's covered up. So what does y equal?
1.
Let's do this. We'll cover up. What does y equal to? That's exactly right.
I got that.
Okay, now here's the goofy thing. Can I graph negative 16 on here?
No.
No, it's like way down here, right? Okay. All right, Sophia. Ready? You nailed that one perfect. I like the heart. Is that okay? Is this an x or a y value? It is a y. So what am I going to do with the heart? Where am I covering? Oh, okay, so negative 8x equals negative 16. Oops. You nailed it. That's it. Now, what would this graph look like? Yeah. I guess if I counted by negatives, negative 2, 4, 6, 8, way down here. 2, 4, 6, 10, 12, 14, 16. I guess I could do that. And then I could call that 2 as well. So this looks like our graph if we were counting by 2's each direction. Right? Increasing or decreasing? Increasing. So if it's increasing, the slope has to be what? Cool. Everyone feel comfortable with that? All right. Let's try this one. This is so we're going to do, this will be my example. And I'm actually going to graph 2 lines on it. I want to graph x equals -3, and I want to graph y equals +2. Okay, so let me bring my graph up. Move this a smidge. Are these special cases?
Yes.
Okay, so I know that x equals -3 is a straight line because they're all straight right now. So where is x equals -3? Do I count 1, 2, 3 this way, or do I go up, or I go right, or I go down? What do you think? Where is this? Where do I count that? First off, where is x equals -3? Where would I even plot a point? Where? That. Yeah. Right there. Everyone agree with that? Okay. X is a special case. X is very close to V, and that means it's vertical. Vertical is very close to U, which means undefined. Right? So this is a vertical line like this. Vertical line, undefined slope. It's not increasing or decreasing. It's undefined. That's what that looks like. So if that one looks like that, what does y equals 2 have to look like? Horizontal. Okay, so I'm going to put my point right here. And does that. Horizontal line has what for slope?
0.
0. Is it increasing or decreasing, Oliver?
Negative.
Do what? Is it increasing or decreasing? Or neither?
Neither.
Correct. Okay. That's it. That's all those have to do. Those are special cases. Okay, so try one on your own. Try this one. Try that one. And Aiden, I'm picking on you next, okay? You did nothing wrong, but we're picking on you. Does anybody need more time doing this one? Aiden, let me ask you this. Are these the two special cases?
Yeah.
Correct. And give me your verbiage of why these are special cases. Not because we already know it is, but what sticks out to you to make it a special case? Look at the purple. What would be special about me calling that a special case? What's it missing? X. And then same thing with the green. It's missing the Y, right? Everyone feel comfortable with that? All right, so Aiden, y equals 6. It's a straight line. Is it horizontal or vertical?
Horizontal.
Horizontal. And where am I going to plot my first point?
Y-axis.
Y-axis. Oh, man. Okay. It looks like that. You already told me it's horizontal. All right, Aiden. Horizontal means the slope is positive, negative, undefined, or nothing. Remember, vertical, that's undefined because U and V is horizontal. So is it positive, negative, or nothing? 0. Nothing. You're right. Nothing. It's okay. Positive would actually look like this. Negative would look like this. This is 0, nothing, undefined. Okay. All right, Aiden. What will the one masked in green look like?
Vertical.
Vertical. Where am I going to go through?
X-axis.
Okay. What point?
Negative 7.
-7. 1, 2, 3, 4, 7. Aiden, what kind of slope does a vertical line have? Remember, vertical is very close to what other letter?
V is close to U, and U stands for?
Questions there? Okay, so far we've covered the cover method when they are in standard form, ax plus by equals c, right? And we just did some special cases. So the last one we're going to do for today will be point slope. We had a big discussion on point slope, right? So let's do this. This is my example. Is that okay? So this will be my example, so let me walk through this one. First thing, I think a good habit we should maybe start doing is let's bring good work ethic back into this. This is grouped. Yeah.
Is that y minus 3 or y minus negative 3?
Y minus 3. So let's make these grouped. Hey. Even these groups. Oh. There you go. Give him another note. Third time's a charm this time.
Bro.
All right, ready? Ready? Just a shout out real quick. What is my point that I'm going to use? What's my point? Huh?
Positive 1.
Reverse that for me. X, Y.
Positive 1, negative 3.
Almost.
Positive 3.
Okay, remember opposite values. Again, we're lazy, so we're putting it back in. What's my slope of this situation?
2, 5.
2 to 5. I like it. All right. So I have 1, 3. Everyone feel comfortable with that? Slope's doing what? How do I get the next point?
Going up 2.
I'm going to go up 2, so on 2 and?
Over 5.
Is this slope increasing or decreasing?
Increasing.
Because it's what kind of slope?
Positive.
Great terms. What do you think? Is that okay? Does everyone feel comfortable with that? Yeah.
Okay, oh wait. Okay, so for the y minus 3, x minus 1, so I know that's how you find your x and y intercepts, but how do you know if it'll be negative or positive? Because it's subtracting.
Oh, okay. So you mean taking it out of here
Yeah.
to here?
Yeah.
And here to here? So the rule just to think about right now in math is anytime something's grouped, and we're really bad in math saying, oh, let's just leave y minus 3 alone. It actually is grouped. It should be in parentheses. So I think we should need to start making a trend. Anytime you take something out of parentheses, it switches the sign every time.
Okay.
And that's from here all the way through calc.
Okay.
Cool?
Mm-hmm.
So that's why it's switched like that. All right, so let's try, y'all try one on your own. And this will be the last one, I think. So you try. Let's not do that. Let's do. There we go. So we're going to start a good trend. We're going to start putting that in groups in parentheses. So now we know it's grouped. So go ahead and try and figure that out. Could be. Joe, I know you're still working, but shout out what the point is.
5 negative 4.
Okay? Everyone look at that. Does that make sense to what we've been doing all along? Any part of that you were like, dude, I don't get it. All right, so 5, negative 4. 1, 2, 3, 4. What's my slope?
Negative 2.
So what am I going to do from this point?
Go down to.
Go down to?
3.
Is this slope increasing or decreasing?
Decreasing.
Decreasing. How do you know it's decreasing without even graphing it?
The slope is negative.
Negative. All right, so I think most of you are going to probably cry yourselves to sleep all weekend knowing this, but I would say take just an honest look at that page we just worked on. And I don't think I need to give you an assignment over the weekend. I mean, unless you guys wanted one.
No.
Come up with something. Is that the deal? Will everyone take a look at that? Yeah. What time we out of here? Don't mind. 48? Yeah, baby. All right, make sure you have everything. Everyone got their phone. Do I have my phone back? Over there? Okay. Hey, guys and girls, make sure you take care of one another this weekend. You know that a smile might change someone's day real quick. Agreed? Have a great. Oh, you don't have to do that. She already knows. She used to watch my videos. Have a great one. Get out of here, guys and girls.